So we are going to take a look at proper form for coordinate geometry proofs. And they're really pretty straightforward. Most of these proofs, the thing you need to really be careful of is that you've explained exactly what you have done with all of your coordinate geometry formulas. That's the main thing that you need to remember. And then, of course, you do need to remember your various formulas. So distance formula, slope formula, midpoint formula. So this note sheet really just gives you a guideline for what you should be doing as you go through your coordinate geometry proofs. So let's take a look at what it says. When developing a coordinate geometry proof, number one, draw and label the graph. State the formulas you will be using. So I would write like midpoint formula or slope formula, or you could just write, I'm finding the midpoint. But usually to have the formula there does help you. I can't tell you how many times students have done delta x over delta y just because they're in a stressful situation and they're not thinking clearly. So the more that you write it out, the better it gets your brain to think about being clear about what you're doing. Show all of your work, including your sketches, coordinates, formula. This is the most important thing. The last thing here, having a concluding sentence stating what you have proven and why it is true, is really the key to your proof. You can't just do the work, okay? So if we look at the problem below, it says to prove that a triangle is isosceles. And really, how do you prove isosceles? You prove isosceles by proving at least two of the sides are the same length. So by its definition. So that basically tells you what you're looking for. And the definition of isosceles tells you at least two of the sides are congruent. And congruent implies of equal length, and length implies distance. So therefore, we will use the distance formula. Okay? So we have a drawing here. It's neat, it's labeled, and we will be using that for the problem. You will use a ruler, no free line drawing here, okay, or a straight edge, not necessarily a ruler. And state the formula you will be using. That's the distance formula. Show all of your work. These can be very, very careless. So the more work that you show, the more partial credit you will get. We're looking for two sides of equal length. So when you find two sides that have the same length, you're good. And we've talked about this before. Let's say that I had gotten the square root of 80 here. Okay? I do not need to simplify that out. Because if I simplify it incorrectly, then someone has to take off points. So as long as you show that those are in fact the same length, you're fine. Unless it says somewhere simplified form. Okay? And then the triangle is isosceles because it has two congruent sides. This is the most important part. You need to have this sentence. Without it and all that crazy work that you're doing, you're not going to get full credit. Example 2. You are given the 4 points and told that it is a trapezoid. Now, this is a little premature for us to talk about, but we have talked about trapezoids before. And the key to proving something is a trapezoid, and we will talk about this when we do quadrilaterals, but since it only has one pair of parallel sides, it's not sufficient to show that one side is parallel. You need to also show that the non-parallel sides are in fact not parallel. All right? So since we're talking about parallelism, we use slope formula. And if we draw the picture, we can see which are intended to be our parallel sides and which are intended to be our non-parallel sides. So we will designate slope of BC. Notice that they say which one they're finding the slope of. Don't just write slope twice. Tell me which lines you're finding the slope of. Okay, and sometimes I'll just do like slope BC like that, just my my subscript there. And then you will say, since the slopes are equal, they are parallel. All right. It is also important to show that the other two are not parallel, and since it only has one pair of parallel sides, and the figure is a trapezoid. Okay. So some of the homework is challenging, so we are going to be working on the back of the homework, sorry about that, tomorrow. So the front of it is pretty straightforward, and those are the problems I would like you to do tonight, just to reinforce this. We'll take a look at those, and then I'll have you guys do, with your groups, you can get through the agony of the back. Okay, so have a great night, and I'll see you in the morning.